So this is me. I'm Govardhan. I'm the co-founder and game director at Xigma Games. I started out as a programmer, but I do game design and art and whatever else is required to make a game with a small team. We started Sigma Games in 2016 when my partner Himanshu and we moved to Bangalore. That's been something that we are talking since we are in college. But in 2016, it seemed as if everything had fallen in place. So we came with our savings and we rented an apartment in Kurmangla. These are some of the games that we made over the course of many years. Our first game is called Rubek. It's a simple puzzle game that we sold on iOS for $0.99. It did well enough for us to allow us to continue making more games. Uh, after Rubik, we made the Bonfire 1 and Bonfire 2. In this postmortem, I'm going to talk about the making of Bonfire 1 and 2, the challenges we faced, and how we overcame them. So, are you guys familiar with the Bonfire? Okay. A few of you are. Okay. So the Bonfire is a survival simulation game. Uh, it starts with a mysterious monk arriving on an island. You start by gathering some resources like wood and food. You can use these resources to construct buildings and craft items. Later in the game, this bonfire attracts some workers. They come to your village, and then you can assign them to various tasks. The game has a dynamic day-night cycle. During nighttime, monsters will attack the village. So you can assign some of your workers as guards, and they will defend your village against these monster attacks. The main inspiration for Bonfire came from a game called A Dark Room, specifically a blog post by Amir Ranjan about how he had made the Dark Room. This Dark Room is a quirky little text-based adventure game. Yeah, it starts with just a single button. The player is only able to gather wood at the start of the game, and then later options expand with the player able to construct buildings and manage resources. Even later, the player an ASCII map such as this opens up. Yeah. An ASCII map such as this opens up, and the player is able to explore the surrounding lands. Also, inspiration for our Bonfire are Kingdom's New Lands and Alto's Adventure. Alto's Adventure is not really similar to our game since it's a simple, what do you call it, side scroller game. But the art style was really helpful for us. Kingdom's New Lands is a side-scrolling strategy game. It has a dynamic day-night cycle. Player is able to construct building during daytime, and at night, monsters will attack his village. So that really helped us finalize some aspects of the game design. So, inspired by these games, I set out putting on paper an idea I had. This was sometime during the development of Rubik, before it was released. The idea was to build a side-scrolling strategy game where the player can gather resources, and different screens of the game would have different buildings, and each building would unlock a new feature. There would also be some nightly attacks with monsters, so that it was not a completely peaceful game. I also didn't want the player to feel stuck in a single screen. So dungeons were planned from the very start, which the players could visit by sending ships or scouts. So this is the first prototype that I made in Unity using for this concept. So here you can see the character is very simple, the art is very simple, and all you can do is press some buttons to gather wood and build some buildings. It was so simple that when you press a single button, the character walks to a location, specified location, and the building game object is enabled. But yeah, and a dynamic day-night cycle was already implemented. So there was a sun and moon sprite rotating in the background. Clouds were also moving. The bonfire was made very simply using particle system. But even with this simple prototype, the game already showed promise. The relaxed nature of the gameplay and the calming mood was already established. Since we were already happy with the prototype, we continued on with development. First thing I did was add some artwork to it. So instead of those basic Unity cubes, I made some sprites in Photoshop. And I used Anima 2D to put them all together inside Unity. Yeah, the fire and all the artwork was improved. Also, some workers were added, NPC workers were added, who would help the player with their gathering of resources. Each worker has some attributes such as hunger and tiredness. So whenever a worker feels hungry, they would try to eat food if it is present in the village. If he sleeps hungry for a few days, he can die. If he sleeps hungry for less than the time it takes for him to die, there is a chance that he can turn into a thief. If workers are too tired, they would also leave the village. So it was going to be not just a survival game, but also a simulation game at the same time. So a game such as this requires a lot of data. We implemented this data using Unity's scriptable object. Initially, it was just a simple script attached to a don't destroy on load object at the start of the game. These data were stored in flat arrays. And each building that you can see here is an enum element, and the enum is used to access the array data. Later, we moved to scriptable objects for increasing the flexibility of it. We use this system for things like building data, character data, resources, and even to decide our AI. In this game, individual NPCs are able to perform any action. The player can give them tasks, such as gathering wood or working in the farm, or a guard. So we needed a way to give this data to each worker. In this scriptable object, you can see here, we have a list of all the tasks required to do each individual action. So if the player sets a NPC's job as a builder, he's able to construct building, add resources, deposit resources, and so on. A logger is able to just deposit resources and gather wood. So this is the way that in just Unity editor, we are able to set all the AI. Here I'm going to explain some implementation details of it. So in order to do this, I started with researching into goal-oriented action programming and behavior trees and utility AI. But in the end, we ended up with a custom logic which worked well enough for us. It's an action selector system. So here you can see that the AI agent starts by checking the condition for one of the tasks which we set in the Unity editor. And when the condition is true, we start a coroutine to complete the action. Once the action is completed, he checks the first action in the list again. So if the condition returns false, he will check the next action on the list. Now, in the previous slide, you can see that the logger, he can deposit wood and gather wood. So the way that works here is that the logger first checks the condition for depositing wood. If he has wood in his inventory, it will return true, and then the coroutine is started to deposit wood. If it returns false, he will check the condition for gathering wood, and then he will move to the tree and gather wood. This system it remained the same for Bonfire 1 and 2, but it was slightly improved based on the increased scope of the project. We made the project announcement very early in our development on our social media. We used to post on Screenshot Saturday, every Saturday, and on our Reddit. And then when we were finally happy with the game, after about 8 months of development, we showcased the game at Casual Connect in Singapore. We received invaluable player feedback there. We observed the players playing our game, and we tried to implement as much of it as we could. During this time, I also got in touch with the original creators of A Dark Room, Amir Ranjan and Michael Townsend, and I sent to them the playable build on test flight. And we were all very happy with the feedback that we received from Casual Connect and the original creators. After Casual Connect, we were very confident about the game's appeal, so we continued with the development. We used Fmod for our sound. So that allowed us to combine multiple soundtracks, multiple layers of sound into a soundtrack, so that depending on the situation, we would have a unique sound effect. For our sound effect, we were able to also randomize various sound effects. So such as when monsters attack the village, they have different barks, and these barks are randomized so that we pick the correct one, so that the players will not get bored of listening to the same sound over and over again. Our sound designer also had this goal of implementing seamless sounds from the very start of the game, so that once you start the game, the sound would not appear. There would not be any harsh transition during loading screens as well. We implemented that by adding the sound effects at the start during game load, and during each scene, different scripts would control the parameters of this sound script. It worked well enough, but it was too cumbersome and players didn't really notice, so we didn't attempt that system again. For Xbox, we also had to re-implement our sounds because Fmod version was outdated, and yeah, our Fmod version was outdated at the time. But in the end, Fmod worked out really well for us. Most people said that most people praised the sounds in our game. So after Casual Connect and after implementing all these sounds, we really started to polish our game. Uh, oh, sorry. Yeah, these background mountains that you see here, they were originally made of a 2D texture. But on phones, when we tested it, it looked too blurry because because these because of the large size of the image and the resolution of most modern devices. So we solved that by replacing these 2D textures with 3D Pro Builder assets. We also use some third-party assets for our particle effects and the water reflection that you see here. Dungeons, we started implementing dungeons in the game soon after we came back from Casual Connect. Dungeons were really important to us because we didn't want the player to stay stuck on the same game screen. The way dungeons work in Bonfire 1 is by having individual rooms that the player can go. Each room is selected from a list of preset rooms so that only the last room is fixed for it to be treasure or a boss room, and the first room has to be empty. Players are able to take a small army to these dungeons by exploring with scouts or sending ships. And based on the room's encounter, buttons are visible on the screen which the player can press to perform actions. I would also like to touch upon the storytelling aspect. Story for us as a studio is not really important. We try to have a minimalist story in our game. We are inspired by games like Dark Souls, which really make the player work. And it is one of the many shortcuts we take because we are a very small studio with no real capability, with no real method of telling more sophisticated story to the player. This can be missed if the player isn't paying attention. In the game, we just have a starting cutscene, and other story is portrayed to the player using in-game events and dialogues. But it worked out well enough for us because that's not really our focus. The boss battle is implemented in the game was implemented in the game at the very end. I think the last month. If the player has been paying attention to the story, they'll notice that the story builds up to reveal an ancient awakened dragon. The player can release a titan from one of the temples in order to do this boss battle. This works out in a manner similar to rock paper scissors, in that these three buttons are available, and the player can click on them. The titan will perform his action, and at the same time, the boss will perform his action. It looked very impressive, but it depended too heavily on RNG and QuickTime events. This art was created in Procreate on an iPad and later refined in Photoshop to put in the final Unity project. We started promoting our game very early using our social media channel. During the last month of release, we really focused on marketing. We reached out to several YouTubers, reviewers, and Touch Arcade gave us 5 out of 5 stars. Videos from Baron Von Games crossed over 1 million views. That really helps spread the word of mouth for a small indie studio like us. Upon release, we received Game of the Day featuring and new games we love in 145 plus countries. Even this is really helpful because we don't really have a marketing budget, but featuring gives us free eyeballs on the App Store whenever players open the page. We released it for as a paid game on iOS for $3.99. On Android, we released it as a free game. Players are able to download it for free, but after playing for 30 in-game minutes or 7 days, in-game days, sorry, the player can buy an IAP in order to unlock the full game. This method worked out very well for us, so we kept it for Bonfire 2 on Android, and we are iterating upon that for our current project. So after Bonfire 1 was released, we were very happy with the reception that we got. So working on Bonfire 2 was a no-brainer for us. The most important goal that we had in mind was to make a worthy sequel because it was so well received by the critics. We also took the player feedback in the sense that players complained that the game was too short. So wanted to make a bigger game. In order to make a bigger game, we had to add more content. Or we can do that by providing a deeper simulation experience to the game so that the systems would increase the length of the game due to the replayability. So we decided to go that route, and we would allow players to design the layout of their own village. We also wanted to provide a bigger experience to the players because length was obviously a concern. Bonfire 1 only lasts for 3 hours, but this time we were targeting for 10 to 12 hours of gameplay. And at this point of time, we are still a team of 2, just Himanshu and I. So we started working on Bonfire 2. The inspirations for Bonfire 2 came from obviously the Bonfire 1, but also games like Kingdoms and Castles, Dungeon Village, Northgard, Banished. Dungeon Village 2 was especially important to us because it provided a simplified colony building experience on mobile. And for us, mobile is still the most important platform. These other games on the list are mainly PC first. So then I started developing the first prototype of Bonfire 2. The first thing that I implemented was a building construction system. Here you can see the progress, which is Bonfire 2 after 1 or 2 months of development. All that it has is a building construction system, and the workers move to the location using A-star algorithm. There is a dynamic day-night cycle implemented using just Unity directional lights, and there is some fog to give some mood to the player. The action selector system from Bonfire 1 was rewritten for Bonfire 2 based on the increased scope of the project, but in principle it remains the same. Here, to allow players to construct buildings, we used one Unity unit as one in-game grid unit, and that really simplified our calculations. Very early in development, it became clear that the A-star was not going to be sufficient for us. So while scrolling Twitter, I came across this thread by Oscar Stahlberg about his making of the Bad North and how he used flow fields to generate paths for his game. The way flow fields work is that the vector is calculated from every tile to every destination. So this allowed us to use multiple destination points, and it worked out really well for us in situations where there are multiple agents on the screen walking to the same destination. Uh, in this slide, you can see there are multiple workers who are spread across the map. Some of them need to move to trees, and the trees are also spread across the map. So the same flow field will direct them to move to the closest tree to them. And when they need to deposit the wood at the bonfire, they will use a common flow field, and this flow field works from any tile in the map, and it points to the same destination. This also worked really well in cases where all of our guards are moving to attack monsters, and these monsters are spread across many tiles. So the same flow field can be used for all these workers, and they will point to all the monsters in the map. We also enhanced the dynamic weather system from Bonfire 1 this time. Bonfire 1 has snow and rain effects. This slows down the workers whenever it happens. This time we also added a dynamic snow shader so that it's not always covered in snow. Only sometimes the land will be covered in snow. We enhanced this by using particle systems from Unity. During snow and rain, we also have stronger winds in the game. The winds affect the bonfire flickering. They affect worker movement speed. The trees will sway in the wind faster. The wind buildings like windmill rotate faster. Their blades rotate faster. This time, the player is also able to construct road tiles so that their workers will not be always slowed due to this snow and wind. Workers, the pathfinding calculation is the pathfinding cost of these road tiles is reduced so that workers will prefer to use roads all the time. One of our goals this time was also to improve our worker simulation methods. Since we wanted to provide a deeper experience to the player. So this time we created many sprites for our workers. They have different heads, hairs, body types for male and female characters. We also added RPG-like stats for strength, agility, and intelligence. After working at any task for a certain amount of time, their stats would increase. Players would have the choice to increase their stats, and every 5 levels, players could select a random skill. The skill was randomized because we didn't want the player to feel like a god. We wanted them to feel like the chieftain of a village who could only direct their workers but not have total control over them. Players can also assign items to these workers in their slots, such as these weapons and armors. These sprites are also created separately and attached to the Anima 2D rig. You can also see the worker health and energy and hunger. So similar to Bonfire 1, if the workers do not sleep on time, they get tired, and then they may leave the village. If they do not eat for a while, they can get hungry, or they can leave the village. They can turn into thieves. So as I said before, our art is created in Anima 2D. During the development of Bonfire 2, we also brought on board a professional 2D artist. Here you can see the Titan character from our game. He's made by creating several different sprites for his head and armor and body sprites. These sprites are combined on our rig to a Anima 2D rig and animated inside Unity. Here you can see the art for our tribal orc character. You can see the various body parts that we made. We also made several variations of these body parts so that we can combine them dynamically at runtime. And then there would be a variation of the final character so that each character would not look the same. We created our 3D, our buildings and environment in 3D using Unity's Pro Builder tools. We used vertex colors from Pro Builder tools so that the base of the building would be set to darker color, and the top would be made lighter. And this was fed into a shader so that we could give a fake lighting effect. We were already using a directional light, but this effect combined with the directional light so that the players would feel there was some kind of bounce light going on. We used separate materials for roof and the walls uh, because we didn't have any textures at the time. So different materials allowed us to provide different colors. Our UI and art goes through several iterations based on the feedback that we receive. On the left side, you can see one of the earliest art that we made, and on the right is the final art. This improvement was only made possible because of the addition of a 2D artist in the team. We try to observe players when we showcase our game at various events. We try to see where they are getting stuck at, and we improve our UI based on this and the feedback that we receive. We also improve our artwork based on our observation of players, basically. But our main goal with our art is to make it more appealing in screenshots, so that whenever someone's scrolling their social media feed and the screenshot pops up, we'll get more clicks and players would be more interested in the game. This time we used Unity's universal render pipeline. When we started Bonfire 1, universal was not so stable. But when developing Bonfire 2, universal was very stable enough for us to use in production. This had several advantages for us. We were able to use shader graph for everything. Here you can see the trees sway in the wind, even the water is flowing. Even the ground is made using shader graph, and it does not use any texture. It's a simple noise shader with some gradients thrown in. Even the final game uses a similar shader for the ground, but it's enhanced to provide more complex patterns. So after 1.5 years of development, we took our game to Tokyo Game Show. We were selected for Indie Arena Booth Showcase. Before showcasing at Tokyo Game Show, we also made a Steam page for the game. Even though it was still early in development, we considered it to be alpha or between alpha and beta. This really helped us with our promotion efforts because Steam at the same time was running a Tokyo Game Show campaign, and we were able to receive a lot of wish lists at the time. Tokyo Game Show was a great experience for us because we received a lot of invaluable player feedback. It was also a great experience as we yeah, it was also a great experience as we were able to see many people experience our game for the first time outside of our studio. Optimization is something that we keep in mind from the very start of the game. Our, we try to have data-oriented programming wherever possible instead of object-oriented. Performance is not something that we try to add on to the game at the very end. We try to use flat arrays wherever possible instead of more complex data structures like trees. Flat arrays and enums are a very powerful combination that we use to store our data for buildings, which we saw earlier. Even with all this, our performance started degrading as we kept on adding more particles and our draw costs increased. So we used jobs and burst system to speed up the pathfinding calculations. Late in the game, we also added a dynamic render scale so that whenever the frame rate of the game drops, the resolution would drop automatically. We made several improvements to our lighting system in the new game, which I'll be coming back to at the end of this presentation. This time, since we had artists on board, we decided to upgrade our storytelling techniques. We made the story we wrote down the story in Excel sheets. Then we provided this to our artist, and he used this to create several frames. He drew out these frames in Photoshop with separated characters. These characters and backgrounds we combined in Unity for parallax effects. We also added some shaders for rain and snow so that it would look much better. All of these frames were combined in Unity using the Unity's timeline feature. We keep on iterating our story through our development. We do not finalize it at the start because story is not really an important focus for us. And we at the start of the game, we don't know where the story is going. We keep working on the gameplay, and we try to edit the story so that it provides context to whatever this player is doing at the moment. This works out well enough for us because players were happy with the conclusion that we were able to provide. I'd like to briefly touch upon the localization that we do. It's not very different from what most other studios would do, I assume. We have a Google Sheet online, which freelancers have access to. They write down the translated words into them. This is downloaded as a CSV file. We convert it into a TXT and import it into Unity editor. The Unity editor reads this TXT file and converts it into a scriptable object. In Bonfire, we had localization since our first game. Rubek had 8 languages localized, but by Bonfire, we were able to have 16 languages in total. We started posting about this project very early in development. The first slide that you can see is the first thing that we posted on Reddit. iOS gaming is especially helpful. We also post every screenshot Saturday on Twitter. This time, we also hired a PR agency to help us with contacting YouTubers and reviewers. By the end of development, we were able to have a Discord community of over 2,000 members. Himanshu will be talking more about this in his panel tomorrow. After more than 2 years of development, we were finally ready to release the game. Upon release, we again received featuring for Game of the Day and new games we love in several countries. As I said before, this really helps out a small studio like us with free marketing. The release of this game was especially difficult because it was during COVID time. All of us were working from our homes. Uh, we were not able to finish many of the content that we had planned from the very start, such as dungeons were left, and a final boss battle had to be cut out. And we were determined to make it happen. But the first few weeks of release, we were very busy to fix all the bugs that we had. So after the release, we split our team, and one team was made to work on the dungeons content, and the rest of our team went on to work on Metal Haven game. The dungeons of Bonfire 2 were going to work in a similar manner to dungeons of Bonfire 1, in that the player would travel room by room, and at any time only a single room would be visible. Different from Bonfire 1 would be that these rooms were not linear. The rooms would be generated in a random grid so that there would be more variety when visiting the dungeons. But each individual room would still have monsters or treasures, and it would work in a similar way. This time, the player could also tap on the ground in order to move their workers. In the main game, the workers would move automatically to fight the monsters. So since the dungeons were randomly generated, our programmer had to create various editor tools to help with the generation. We knew that dungeons would have several complicated effects, such as some layouts would not be possible to traverse, or the AI would get stuck in some corners. So we had to take care of many edge cases, but in the end, we were able to provide a satisfying dungeon experience to the players. Now we also have a 3D artist on board, so we were able to upgrade our artwork. Instead of using simple Pro Builder models, we create our art using Blender 3D. Yeah. We create our art using Blender 3D. Instead of using a simple shader for different materials, we create a texture sheet. In this slide, you can see a 256 by 256 texture sheet that is used to texture all of our dungeon assets. The advantage of this method is that we can render all of our dungeon assets using a single draw call. But the disadvantage is that when we want to create more complex patterns, we need to add much more geometry so that the UVs can be assigned to the correct slot on this texture. I'd also like to briefly touch upon our business model at this time. We started out as a premium game studio. Until Bonfire 1, all of our games were pay ones to download. But with Bonfire 1 on Android, we tested out a download for free model, and the player could buy an IAP in order to unlock the full game. This worked out so well that we continued it for Bonfire 2, and we are expanding it for our current project. Our revenue from this model has crossed the revenue from pay to downloads. This model was inspired by the by the model used by Inside from Playdead on iOS. It's a paid game on PC, but on iOS the players can download it for free, and with an IAP they can unlock the full game. So our current game is called Metal Heaven. We have a playable demo of this at our booth in the showcase floor at booth number 22. We've taken all of our learnings from Bonfire 1 and 2 in order to make this game. We started with the Bonfire 2 code base, and we have an increased team now. So this has allowed us to create in 1 year what we were able to achieve maybe in 2 or 3 years using Bonfire 2. So we've done several improvements on the Bonfire 2 code base for Metal Haven. We've replaced the custom action selection logic with behavior trees, since our focus this time is on action instead of survival and simulation elements, and behavior trees would work very well for such a situation. We've also enhanced our worker pathfinding system with a squad-based unit separation system. So we are combining our flow fields with flood fill algorithm. So in this case, you can see multiple units. They can reach to multiple destinations, and the flood fill algorithm would give them their separate paths, their separate destinations. We also replaced the Unity's lighting. This time we do not use the directional light of Unity. We are using a custom pipeline based on matcap shaders, and we are combining it with various effects like emission and height fogs. This is much more optimized than the Unity's directional light system. So we are also able to add post-process effects to our game this time. This is our development team. We started out as a 2-person studio in Kormangla, but over time we have expanded to a team of 7 now. The game would not have been possible even without a single one of them, and it is thanks to their effort that we are able to create this. That brings us to the end of our presentation. Thank you all for listening. If you have any questions, I can take that now.
Hey guys, we are running short of time, so we'll take only 2 questions for now. If you guys have any other questions, you can please feel free to reach out to him directly. Thank you.